All right, guys. Before we get to this here, are there any questions on the homework? Any questions over any of the homework assignments so far? Any questions on over any of the homework assignments so far? Okay. Was anybody able to find a number when multiplied by itself, you get a negative number? So what? So negative 5 times itself would be negative 5 times. So negative 5 times negative 5 is 25.
Oh, I thought we were dividing. I don't know why. My brain
Anybody come up with one?
No. What about just like negative 5 times 4?
By itself.
Oh. Is there actually one?
So let's think of this. So we're saying that some number, we'll call it I, times itself. So we're saying it's squared is going to equal, let's just say, negative 1. So we're saying that I times itself is negative 1. That's really what we're trying to get at. A number times itself is a negative number. We'll just say 1. So we could square root both sides. The square root of I squared is I. And we're not going to worry about the plus or minus. But really, for this to work, we're saying that I is the square root of negative 1. And you can plug that into the yellow calculator to see what it is, and it's going to tell you that it is an error. Because again, what are we saying? A number times itself, that gives us a negative. And as we just saw, well, a positive times a positive is a positive number, yes? A negative times a negative is a positive number. So really what we're doing with this here is we created this number. This imaginary number, I. And that is true. Whenever you see kind of this I with a little bit of a curl, or the other way that they will write it, is an I like this here, is the imaginary number. I is an imaginary number. And we will use this to start solving. Because when we talked about earlier, and we mentioned a few times, especially in 3.3 when we were talking about graphing, where we said these don't have any real solutions, is because the solution is imaginary. It's a complex number. It's an imaginary solution. This is where it comes in. Is an I. Our imaginary number, we will call I, is equal to the square root of negative 1. So really from this point on, if we have a negative square root, it means that we're going to have I. I is the square root of negative 1. Because I, by definition, is the square root of negative 1. Questions on this here so far? And this is going to help us, especially when solving. Like the other day where we were taking the square root of negative, I believe it was 5/2. So part of the answer is going to be I. That's what's going to let us take this here. Now, if we look at the next part, we have these here, these square roots. Now, we could try taking the square root of negative 25. So I can pull the calculator up here. I'll clear all this out. Clear. And we could say second square root negative 25. And again, non-real answer. Because again, as we've said already, we can't multiply a number by itself and get a negative. But what did we just say I was? I is square root of negative 1, yes? So what we can think of this here, so the square root of negative 25. Well, that's the same as saying negative 1 times 25. Because negative 25 is the same as negative 1 times 25, yes? Well, we could say this is the same as the square root of negative 1 times the square root of 25. But we know what the square root of 25 is. Square root of 25 is what? And what did we just define the square root of negative 1 as? So the square root of negative 25 is 5i. So anytime we have a negative inside that radical, it's going to come out as I. The negative is going to come out as I. Questions on this so far? Any questions on any of this so far? Now, the nice thing with it is with a lot of these radicals, the yellow calculator, the 30xs, will simplify radicals for us. But they won't simplify this here. They won't simplify the square root of negative 72. Because again, negative 72 is not a real number because of the negative.
So wouldn't it just be 75?
So the negative indeed would come out as I. And we're looking at the square root of 72. Now the yellow calculator, that 30xs, will take the square root of 72. It will do that just fine. Because we'd have to look for perfect squares inside 36 or 72, which is 36. And the square root of 36 is 6. So we had 6i square root of 2. But again, the yellow 30xs calculator will take the square root of 72. It'll tell us it's 6 square root of 2. Do you have one? Yeah.
The yellow one works.
Yellow. You're welcome. So you can go on and type square root 72 in there, and it'll tell you that it's 6 square root of 2. We throw the I in, because again, that's where we got the negative out. Now, if we look at this next one, negative 5 times the square root of negative 9. Yes, sir. Huh? Okay. So
So we can make a 5 with square root of...
because we could try plugging that in, and it's going to tell us it's non-real answers. Because it doesn't want to take the square root of negative 9, because the square root of negative 9 does not exist. But what do we know about the negative? Yeah, because we could pull the negative out, because we know this answer is going to have I, yes? Because we're really saying we have I times negative 5 times the square root of. So it would be,
Why?
because the 5 is
Okay.
negative.
I was like, why?
So is there a way you can just ignore both the negatives and put it back on there?
Yeah,
Like type in the calculator anyway?
yeah, because in the calculator you could type this in as negative, yeah, negative 5 second square root 9, hit enter, and it'll
Is
give
how we
you,
can solve all of these?
and then you can put the I back in.
Yeah.
So, I don't mean this to sound rude,
Yes.
but I don't understand why.
Now, this here, imaginary numbers, actually comes up more often than you think, especially if we're talking about electronics, anything dealing with circuits or electricity. Because when we talk about it or define the circuit and define the mathematics behind the circuits and the properties of how much electricity can flow through it and applying the properties of that there. Now, with anything, it always has the potential for energy to flow, yes? So if your phone is turned off or as this one here is turned, this calculator is turned off, is there any energy or any electricity flowing through it? No. But can there be? Yeah. So these imaginary numbers really come into this because in the moments where it's not on, electricity is not flowing, we're in what we consider the complex or imaginary plane, and imaginary numbers are in that interval for where it's not turned on. So we needed a way to define it. We needed a way to signify or calculate these numbers where we get solutions like these here, where I'm having to take the square root of this negative number. I need a way to quantify it. I need a way to actually talk about it. So we came up with this here, this I, the square root of -1, to actually help us signify it. Now, the graphing calculator, we've already stated, does not like radicals. So second square root 72, it doesn't like it. Well, it's not that it doesn't like it. It doesn't leave it in radical form. But it does good with perfect squares, yes? Now, under mode, there is this one that's called real, yes? In this mode, it's telling the calculator, I want you to only calculate in real numbers. A plus BI, if I hit enter on this here, second quit, I'll go back to the square root of -25.
What? Okay, how'd you do that again?
Now, the thing is with this, because it'll work just fine with everything else. But the issue that comes into play, second square root -72, it doesn't do it. It will give us the answer. That is the square root of 72, or -72. But again, what we want, and when we give our answers, we want it in radical form. So for any of them that are not perfect squares, it doesn't work as well. But if it's a perfect square, it works out just fine. Although, for most of these here, I can take the negative out as I, use the 30xs, and it would give us the answer.
Yeah.
Let's look at these next set. So the next one is negative, or square root of -4, yes? Well, we know the negative is going to come out as because the square root of 4 is 2, the negative is I. So -12, square root of -12. So the negative would come out as I, yes? 4 times 4 is 16. So we'd have I and then the square root of 12. We would need to simplify the square root of 12, but again, the 30xs will simplify it for us. Because if we're trying to simplify this radical, we're looking for perfect squares that go into 12. Well, the first perfect square that goes into 12 is 4. 4 times 3 is 12, yes? Yeah. Square root of 4? 2i square root of 3. Or if you plugged in the square root of 12 for the 30xs, it'll tell you that it's 2 square root of 3. And we plug the I outside of the radical. I wouldn't go back in. So any questions on the first two? So 2i square root of 3. Now number 3, negative square root of -36. Well, the negative inside the radical is going to come out as I, which leaves us with negative square root of 36, yes? So the square root of 36 is indeed, so it's -6i. Now in the next one, we have 2 times the square root of -54. Well, the negative is going to come out as I. So we have 2i square root of 54. So now we need to figure out what that is. So you could type it in as So 6i square root 6. So in the yellow calculator, you can type in 2 square root of 54, hit enter. Because the only thing we can't type into it is I. And it'll simplify it for us. Because what it's telling us is 9 will go into 54. 9 times 54, or 9 times 6 is 54. Square root of 9 is 3. We leave the 6 inside. 2 times 3 is 6, giving us this here. Questions on any of this here? Question on anything we've done so far? We good with this here? Okay. Now the next thing we're going to look at is powers of I. Powers of I. Now this might seem a little weird at first, but again, just stay with me and let's see if something happens. Now we started off and we've said already, I is the square root of -1, yes? Now if we multiply I by itself, I squared, what are we really saying? We're saying we're taking what? The square root of -1 and squaring it, yes? Because if I say I squared, I is just the square root of -1. So we're saying the square root of -1 squared. If we square a square root, they do what? So really, I squared is what? -1. So I squared -1. I squared is -1. Because again, I is the square root of -1, square root of -1 squared, the square would cancel, giving us -1. Okay. I'm going to multiply it by I again. So we get I cubed. Well, I cubed, well, that's the same as saying I squared times I. We're multiplying I by itself 3 times, yes? Well, we already found out what I squared is. I squared is -1 times I is -I. Okay. All right, well, let's do it again. Let's say I to the 4th. So I just keep multiplying this by I again. And again, let's just stay with me here for a second. Well, I cubed, we already found is, so we have -I times I. Well, I times I is squared. So we have -I squared. Well, what is I squared? So we have -1, which is 1. So I to the 4th is 1. And again, I haven't made a point yet. So again, all I've done is I'm just taking powers of I. I'm just multiplying I again and again and again.
Is this how far we're going to go?
So let's do it again. Well, I to the 5th is just wait 1 second. Just stay with me. Stay with me. We haven't made a point yet. Guys, what's I to the 4th? So I to the 4th is 1. So that's 1 times I, which is I, yes? Well, I to the fourth, we already saw is 1. So that's 1 times I, which is just I.
It's
Okay.
just a pattern, pretty much, right?
Yes.
Can you go all the way to like I
Mhm. Now,
He's already at 6.
I to the sixth, which is what? I to the fifth times. So I to the sixth, we could say is I to the fifth times I. Well, what is I to the fifth? So we have I times I, which is I squared, because I times I, anything times itself is squared.
Making stuff up now.
And I squared is what?
No way. Killing my brain cells. This is like Aaron trying to explain how 2 times 2 is 5. 2 plus 2 is actually 6.
What is going to be I to the seventh?
Oh my gosh. I to the 6.
Negative I.
Yes. I to the sixth is?
I cannot take this home and I'm showing my mom and I want so she's gonna be like, what in the world? And I'm gonna be like, and guess what?
What do y'all think I to the eighth is?
I bet it's like 1 or negative 1.
I'm gonna
Wait,
say
it's
negative
1
I.
because it's negative 1
Because where are we starting? I, negative, so we start out with I, yes?
because I negative
So we went I,
wait.
negative 1, negative I, 1. I, negative 1, negative I.
How am I supposed to remember that pattern?
Remember where it starts.
At 1.
So,
1J1J1J1.
so what were our 4 values? I, I, negative 1, negative I. For any power of I, we only have one of 4 answers. It's either going to be I, negative 1, negative I, or 1. These are the only 4 values, guys. These are the only 4 values of I that we can have. Because whenever we have a power greater than 1 attached with I, we have to simplify it. And it's going to give us one of these 4 here. Now,
You will put this on the test where we have to make I powers the I, right?
so guys, hold on. Just give me I to the n. I to any power of n. What we can do, instead of doing this here, we can take n divided by 4. Because how many different answers did we have? 4, because it's I, negative I, or I, negative 1, negative I, and 1. Because those are one of the 4. Now, we don't care what the first 2 numbers are. Because whenever we divide by 4, the decimal, guys, you're already quitting out way too easy. You haven't even let me finish. If I divide by 4, what decimals do I get? 0.00, 0.25, 0.5, 0.75. Quarters. If you divide it by 4 and the decimal is 0.25, your answer is I. If you divide by 4 and get 0.50, it is. If you divide by 4 and get 0.75, and if you get 0.00 or you don't get a decimal, it is. That is it.
Okay, that's not bad. Okay, it's basically like
Mhm.
but 1 it goes positive, negative.
Because again, this is already written down here. When we evaluate it, we have 1i, negative I, and negative 1. So if we wanted to evaluate I to the 27th, we could go through like we were doing, going I squared, I cubed, all the way up there. Or I can take 27 and divide it by 4.
And then you look at the last two or the first two.
Because n is our 27. Now if we divided this by 4, because it's going to give us, I think, 675. I don't care about the 6.
It was the negative I. So the answer's just negative I.
Yes.
Okay, makes sense now. I think what we learned was that you really always were able.
Now, one of the things I will say is I squared, knowing what it is off the top of your head is going to be nice to know, especially for this chapter. Because it works out that there are 4 points. Yeah. Because we have 1 I, negative I, or it'd be negative 1, negative I. So we have only 4 spots where it can go, and it's going to, yep. And it rotates around, so it's going to be one of these 4 points. Because I to the 0 is 1. I squared is negative 1. I cubed is negative I to the 4th. Yep, and really what the 6 is telling us is that we went around this circle 6 times, and then the 0.75 tells me we went 1, 2, 3. So it's just rotating around these 4 points. Now, knowing that I squared is negative 1 is helpful, because when we multiply, they bring them up on the ACT, where you're having to multiply these together or simplify. Knowing that's helpful, because it solves them a little bit quicker. They do some of these here, but we do multiply some, because we'll look at multiplication most likely tomorrow. Now, if we want to evaluate I to the 34th, we're going to divide it by 4. So,
So it's going to be negative 1. Yeah, negative 1.
47. Yeah, we get
I feel like you got me. I know.
something 0.7. So again, we divide it by 4. And again, it's going to give you a number point, and this one here, I believe, is 0.75, yes? Which is negative I. Now we can look at the next one, I to the 65. So 65 divided by 4 is something 0.25, is what you all were saying? So this is I, yes? Okay, I.
1040.
Now let's see here. If you notice on the graphing calculator, the decimal right above it in blue is what? In blue above it is what? So if we go second decimal, it will pull up I. So this here is telling us we have 1 plus. This E is its way of saying 10 to the power. So what it's saying is that we have 1 plus 4 times 10 to the negative 12I is what this is saying. So that'd be 1 plus 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What, guys,
That's a full number. So
what is this really close to?
so it's just or 1.
I'm just gonna put one. I'm gonna put
Okay, it's 1.
Now, what was 1040 divided by 4? Point.
no nothing.
It's just 260.
So if it doesn't give us a decimal, it is,
Automatically 0, 0.
which tells us that this is.
Okay.
Now, we could say I to the 65. So I'm going to pull the calculator back up. Say second I to the 65. It'll do it, but if we get to numbers that are really big, it gives us that essential 0. Because for the one before it, 4e to the negative 12I, that's just 0. Because again, it's having to graph and approximate, and the pixels on the calculator, it has a little bit of an approximation error. So that part's 0. So we can do it in the graphing calculator, but once the powers of I get so big, we get that approximation error. But again, we can just divide it by 4 and get our answer. So any questions on any of this here so far? Are you ready for the next part? Sum and difference of complex numbers. To add or subtract two complex numbers, add or subtract their real parts, and add or subtract their imaginary parts separately. Because whenever we talk about a complex number, it's going to come in the form of a plus bi. A is the real part, bi is the imaginary part. And we can almost treat I in these cases as a variable.
So then you would just do 8 plus 5, negative 1 plus 4.
So looking at this here, so we have 8 minus I plus 5 plus 4I, yes? So because it's plus, we can just drop the parentheses in both cases, yes? So we're saying we have 8 minus I plus 5 plus 4I, yes? Well, what are our real parts? 8 and, so we're saying we have 8 plus 5 plus 4I minus I, yes? I've grouped the ones that are the same, are like terms. Well, what is 8 plus 5? What is 4I minus I? That's it. The only time we'll have to do something is if I gets a power greater than 1. Because I cannot have a power greater than 1. Because that would be the equivalent of leaving your answer as like the square root of 36 squared. No, that can simplify down. We're going to simplify it down. Questions on these here? We ready for the next one? 7 minus 6i minus 3 minus 6i. So the first one, we don't have anything in front of the 7 minus 6i, do we? So we can drop those parentheses, which tells us we have 7 minus 6i, yes? But what's going to happen to the 3 minus 6i? Because we're applying this negative to both, yes? So we would have negative 3, what? Because we're subtracting 3, so we're saying 7 minus 3. And negative 6 minus negative 6i. So we're saying that we have 7 minus 3 minus 6i plus 6i. Again, I'm just regrouping the terms. What is 7 minus 3? What is negative 6i plus 6i? 0I, which is just,
0. So it should be
yeah, 0I. 0 times I is 0. So we just have 4. Questions on this here? Because, I mean, we're doing almost the same thing as if we had said 7 minus exactly 6A minus 3 minus. We treat it like a variable until it has a power greater than 1, then we've got to reduce it. So 13 minus 2 plus 7I plus 5, yes? I'm going to try this here. Because I just typed it in exactly as we have it, yes?
okay. Well, that's bougie. That's bougie.
What can we do?
So again, if we work this out by hand, we'd have negative 2 minus 7I plus 13 minus 2 is 11. Negative 7 plus 5 is second decimal. Yes, sir? Okay. From Michaela Johnson? Caitlin Johnson.
She had a list on teacher.
Okay,
So she won't be here for about 3 days.
that's fine.
Take it out. And then she has a ball game Friday. I have to have my ticket. I would have to go see.
She asked me for champ.
You guys are steps up for the head.
There's no homework for champ. All right, guys. Let's look at this one here. So 2 plus 9I plus 11 minus I plus I mean, we can type it into the graphing calculator and it'll tell us it's 13 plus 8I. Now, if we did this by hand, because it is plus, we have 2 plus 9I. 2 and 11 are like terms, yes? 2 plus 11 is? 9I minus I. 9 minus 1 is? And it would be positive. And that's it. Questions on this here? I think we feel comfortable with these here, yes? Multiply. Now, when we multiply, here we're just distributing the 4I. So, yeah, so 4I times negative 6. 4 times negative 6 is 24. And we have I. 4I times I is going to be plus 4I squared. Now, we can't leave I as I squared. So we'd have negative 24I plus 4 times negative 1. Because I squared, 2 divided by 4 is 0.5, which is our negative 1. Yeah. Or if we wrote it in standard form, it's going to be -4 minus.
Which is it okay to write them both letters?
Bless you. If they want it in standard form, we want the term that doesn't have I first. We want our real number first, then our imaginary number second. Because it was 6, or -6 plus I. Let's look at the next one. So again, we can distribute the 15I to both terms, which would give us -15I. -15I times 2I. 15 times 2 is 30I squared. -30 minus